Welcome to our last video of section 5.6 and the last video of our Hybrid Tuesday class. So I just wanted to explain this graph to you a little bit. This is a graph of exponential decay in terms of half-lives. So we have our initial amount, and then down here we have 1/2 of the initial amount, and that's at time t. So t is the time to decrease by half. And so 2t is the time to increase by half again. So to go from 1/2 to 1/4. And that's 1/4 of the original amount, or half of our half-life. And 1/8 is 1/8 of the original amount, or half of our 1/4 half-life. So decay rate and half-life are related in the same way as our growth rate and our doubling time, as long as we acknowledge that the sign of k is negative. So, example 5 says the oldest human remains were found in North America, contain 21% of the carbon-14 expected in a living organism. We know from laboratory experiments that the half-life, let's undo that. The half-life of C14, or carbon-14, is approximately 5,750, and that's years. I forgot that part. Use this information to predict how long ago this man lived. So, in order to do that, we are going to have to use one of these half-life formulas here. So if we want to find k, remember k is the decay. So what we are going to do is we are going to say k equals the natural log of 2 over the time it takes for that to increase by 2, which is that 5,750. So we're going to take the natural log of 2 over 5,750, and that's going to give our k. And so when I do that, I get 0.00012. That equals k. So the next thing that we need in order to use our equation, P of t equals PO, e to the negative kt. So now we know k. We're trying to find time. So now what we want to think about is this sentence right here, where they were found to contain only 21% of the carbon-14 expected in a living organism. So if only 21% of the original P sub 0, it doesn't really matter what P sub 0 is, we can say 0.21 P sub 0 equals P of t, because this is 21% of the original. So that's what I'm going to plug in for P of t. And even though we don't know what the initial amount is, you're going to see it's all going to end up canceling out anyway. So we have 0.21 P naught equals P sub 0, or P naught, e to the negative 0.00012 t. So the first thing we're going to do is divide both sides by P sub 0, or P naught. And now we get 0.21 equals e to the negative 0.00012 t. Let's take the natural log of both sides. So ln of 0.21 equals negative 0.12312 t. And that's times the natural log of e. And you know what happens with the natural log of e. It equals 1. So I just don't even write it, mostly because I'm lazy. And we divide both sides by negative 0.00012. And when I do that, I get 130005.3979. So what does that mean? That means the remains are approximately, so instead of writing the word, I'm just going to do the sign, 130,005 years old. That's pretty old. This is real, by the way. So, using carbon dating, they found out that's how old they are. So, this is the end of the 5.6 video. Let me give you your homework. I'm just going to write it right here because this is a blank space. So, your homework for 5.6 is on page 373. You're going to be doing numbers 1, 7, 9, 17, 23, 25, 27, and 29. Okay? So you have your 5.5 and 5.6 homework from these videos, and hopefully you have watched these by Thursday's class, and so I can go over any homework questions with you. Once again, please email me at JamieLynn.Shepherd at, that's an @ gmail.com with any questions. I love questions, and I will get back to you very quickly. Unless you're watching these videos at like 1 o'clock in the morning, and then you'll have to wait until I wake up. So have a wonderful Tuesday. Hopefully you just set aside the class time to watch these videos since you are not in class. I will see you on Thursday.